Hello students, welcome. In this session, we are going to discuss about or talk about the important concepts from the programming language in C. My name is Ketan Pachpande and have been working with the product based company from more than a decade now as a C++ developer with the area of expertise as data protection. So with that small introduction, let's start with the session. Here I am going to, first of all, I am going to list down all the concepts from the C programming language that you should prepare. So starting with the memory organization, how the memory is allocated for a C program, or how OS operating system allocates memory for a program or process, such as code section, data segment, data runtime stack, and the heap section. So those concepts are important before you start with the actual C programming. All right. The data types, declaration of variable, the functions, what is the meaning of function, what are the types of functions, what are the different operators, logical, arithmetic, relational, bitwise operators, the control statements, if and else, switch case, and the loops, for loop, while loop, do while loop. Now continuing here, the pointers, one of the very important topic, followed by, in pointers we will in details later, I am going to tell you which all topics under pointer you should prepare well. Parameter passing techniques, by value and by reference. Recursion, I am also going to discuss one recursion problem and how to approach to the solution. Storage classes, auto storage class, static storage class, we have 4 storage classes. And finally, the static and dynamic scoping rule. All right. So overall, you have to complete this all topics, out of which the most important topics are, as I said, one of the important topic is pointer, and the other important topic which is a recursion, and it carries almost 80% or more for the gate. All right, and not for the gate, but if you appear for any competitive exam other than gate or interview or any written test for your placements, these two topics are going to really help you. Now under this pointers, I'll discuss all the subtopics, and of course one of the problem for the recursion also. Now straight away coming to the pointer topics, because it carries, the two topics carries more than 80% weightage. I would directly come to the pointers, because in this session I just want to focus on what are the important topics as far as the weightage is concerned. Now do not try to directly jump to the pointer topics. Why? Because before you learn that pointer topics or concepts, you should be very confident, or you should be very clear in the basics, the declaration of variables, different data types, int, char, float, double, such as derived data type also, arrays, structure. That concept should be very clear before you touch on the pointers concept. And you should also know the control statements very well, how the for loops, the loops works, and the switch case and the if else control statement works, branching statements, branching techniques. All right. And as I said, just don't directly jump to this topic when you prepare systematically. All right. But once you are clear with all the basics before the pointers chapter, now it is time to focus and give more time to this pointers topic. So let me list down. The first one is the pointer basics. What is the meaning of a pointer? How the pointer is declared? How it looks like in memory? So to give a small example of pointer, in this session really I am not going to talk about many numericals or so, but the approach I am going to tell you. So when you have a basics, any problem on the pointer, try to draw the memory block. For example, if I have an integer, clearly show the memory as a block, as a rectangle you can show, and assuming that the integer take 4 bytes, you clearly show that it is taking 4 bytes and the value is stored here is 10. Now any dummy address you can consider for pointers problem, remember. So here I am going to consider a dummy address, suppose 500. So if the first byte's address is 500, then this would be 501, 502 and 503. So how many bytes the integer has taken in the memory? 4 bytes. Yes, the integer can be 2 bytes or 4 bytes, but you can assume it is 4 bytes as of now. All right. Now coming to the pointer definition, I declare a pointer. Now pointer is also a variable, that's why I am going to show a separate, it is also a variable like a, but int a is capable of storing an integer value. This variable p is capable of holding someone's address, So how can I put an address here? By ampersand. What is the expression value? Ampersand a, the expression value is 500. The ampersand on a variable name gives us address of that variable. And here we have 4 addresses, so out of which only 500 is the expression value here, and that expression value gets stored in the P. Alright. Why I am telling you this? To tackle any problem of the pointer, as you write the program or as you read the program, try to clearly draw the diagram such as this. And as the clean is your diagram, you will take less time to solve that problem statement, and your answer would be correct. You will get a correct answer. I mean, if there are many variable, pass by value, pass by reference, and there are complex program on pointer, you should always consider doing this. All right. Now the second, in the pointer basics, you should also learn pointer to pointer, void pointer, null pointer. All right. And why a pointer needs a data type? Like I say int star p. Now why this int is needed here? Why the data type should be associated with a pointer? Okay, all right. So if it is an integer pointer, float pointer, structure type of pointer, so you should have that clear understanding of why it is required. The next topic you have to learn in the pointer is pointer to array and array elements. Okay. Let me first list down the topics, then I'll talk about the one-dimensional array also. Pointer arithmetic means what operations are allowed on pointer and what are not. If I have 2 pointers, int star p is equal to ampersand a, suppose some variable you have in your program, int a, and if I have another pointer, int star q is equal to ampersand b. When I have 2 pointers, what operations are allowed on these 2 pointers and what are invalid or illegal operations? Let me quickly tell you that. So suppose if you do p plus q, this is invalid operation. This is not allowed, illegal operation. Similarly, you cannot do p into q, not allowed. You cannot take the division of 2 pointers. You can take the division of 2 integers, but you cannot take the division of 2 pointers. Similarly, you cannot take the mod of 2 pointers. And all the bitwise operations such as left shift, right shift, one's complement, All these are not allowed on pointer variables. Now what is allowed? Allowed operations. On the pointer, adding a constant number as an integer, not just a number, but you can say p plus a, you can say p plus I, where I or a should be integer only. Alright. This is called as jumping to the some next memory location. This is allowed. P minus 1 you can do. You can do p minus 2 also if you want to. Alright. P minus q you can do. You can take the difference of two pointers, by the way, p, q. Here I have not listed the difference, but here you can list the difference also. I mean, that is a allowed operation. The p minus q would give you the memory number of memory locations between p and q divided by the size of pointer type. That is important. All right. Anyway, so not going into details here, but this is allowed operation. Similarly, you can do the relational. You can use the relational operators on pointers such as p greater than q, q greater than p, or p equal to q. All relational statements or operators you can use here. All right. Yes, as I said, pointer to pointer under basic you can cover. Yes, one of the very important topic is pointer to dynamically allocated memory. Now, how to allocate the memory dynamically? Using a malloc and calloc functions. So, suppose in a program, let me take void star p, some piece of code is here. Now, when you want to allocate a memory dynamically, you use malloc function or calloc function. And to the malloc function, you pass the number of bytes to be allocated. You can just pass 10, or you can have some expression also here, a plus b or c, some expression that gives us some number, integral type of expression. Malloc n, that much of memory will be allocated, and operating system will return us the first byte's address. So the memory is allocated 10 bytes, and the address of the first byte is returned, which can be stored in your local variable p. P is a local variable. So, and when this memory is allocated 10 bytes at runtime, after execution of all this code at runtime, at this point in time, memory will be allocated and address will be returned. And you use the memory for any purpose. You can store integers here, you can store floats here, you can store structure variable here. Any data you can store here, means you can use this memory as you like. And after using it, you can just free it out and rest of the program. So it is in purely the programmer's hand when to allocate memory, when to deallocate memory, what is the size of memory the programmer needs to do some to perform some task or some job. Alright. So that is pointer to dynamically allocated memory, or memory allocated at runtime. The next topic you want to learn is pointer to structure. Structure is one of the very important topic in computer science. I mean, as far as the operating system concepts, when you talk about Windows or Linux operating system, the process when you learn or when you launch a process in your computer, a process is nothing but data structure. So if you look at the documentation of these operating systems, you will clearly see struct keyword used for process, pointer to structure. Then the array of pointers, if you want to if you want to have 5 pointers to different some variables or some data, instead of declaring 5 different pointers, you can have the array of pointers. In short, you can have such diagram where each one is a pointer here, pointing to some data, pointing to some data. How to declare, suppose this is an integer. I want to hold the address of all these integers or some data. You can declare a pointer int star p4, isn't it? So instead of int star p, yet if you put a bracket, that is nothing but the declaration of array. So I have declared an array and each element is a pointer to someone. Each element is a pointer to or storing the address of someone. That is a array of pointers. One of the again important topic from the GATE perspective or other competitive exams is pointer to strings. Many questions they will frame around the strings basically, and they'll ask what is the output of this program. Okay. Another not so important, but yes, you should know pointer to function as well. I have not seen many questions, but yes, please don't skip that topic as well. Two problems you need to again learn in the pointers concept, that is dangling pointers and memory leak problem. All right. And as I said in the basics, you can also learn the you have to learn the void and null pointer as well. All right. So these are the subtopics under the pointers chapter. Spend enough time to understand every topic here. Don't just hurry to move to the next concept and just don't overlook at the concept. I'm saying try to get into the concept, first learn basics, try to write your own programs, try to execute it. As you execute it, you understand it better. All right. Now, one of the topic I'm going to pick up, and what we have to learn here, I'm not really going to teach you 1D array. I'm saying I'm going to teach you, I'm going to tell you how to approach the problem statement, how to make the concepts clear in the mind. That is important here about the pointers. So I'm going to discuss the pointer to one dimensional array here. Okay. For example, in a function, let us say main function or any other function 1, function 2, I am going to have, instead of A, I am going to have the employee ID of 5 employees. I want to store employee ID of 5 employees. So that's how you declare the one dimensional array, right? So as a basics, what you should learn about this array, one dimensional array. Let me draw the diagram. All right. Now when this statement, when you declare an array, when the memory is allocated at whatever time, here it is a local variable, here it is a local variable. That's why memory will be allocated in the runtime stack. If I move this statement outside the main, this array becomes global. And memory for the global variable is allocated when? At load time and where? In the data segment of the process, right? Considering here it is just a local variable, I am going to clearly show the array here. In the one dimensional array, of course, here every element is an integer size, integer type. Consider integer, one integer is of 2 bytes. 5 into 2, total 10 bytes will be allocated. Agree? Ten bytes. 2 bytes each. Now here I am going to give one dummy address, let us say 700. So 700, 701, 702, 704, 706, 708. So as you come across any 1D array, clearly have the diagram on the paper or in your mind. And don't just stop here, this diagram is not complete yet. The name of the array, here name of the array is EMPID, employee ID. You have to again show the employee ID box. And it itself is a constant pointer to the first element of array. What it is? Constant pointer to first element of array. Means what it stores is address 700. Actually it is not a variable, that's why it is written as constant pointer. Do not think that the if this is a pointer, we can change it. Alright. So changing the name of the array pointer is not allowed because it is not a variable. It is not allocated memory. Memory is only allocated for this 10 bytes. Alright. Now, since it is a constant pointer, you cannot do this. Suppose if I have int a is equal to 10. Now since this is an integer type of pointer, agreed, you see, integer type of pointer, but even if it is integer type of pointer, doing this is not allowed. What error you will get here? You will get compile time error here, compile time error. So you cannot make this point to something else in memory. It will only point to 700. It is supposed to point to only 700. Alright. Now with the help of this pointer, how can we access the elements? Okay. So with the help of this pointer, if I want to print first 3 elements, let us assume that. Okay. First I have to assign the elements, so I can put the values also if I want to see here. Here only I will write. Alright. You can simply say value at empid is equal to 10. 10 will be stored here. Now with respect to the pointer, you can access the element, or using this statement also you can access the element. Employee ID 1 is equal to 20. This is also fine. So these are the two ways of accessing the elements. If I want to access the third element, I can do like this. Employee ID plus 2 is equal to 30. Now, what is mean by a plus 2 here? Let's understand. What is employee ID? Just look at the employee ID. What is employee ID? 700. 700 plus 2 is not 702. 700 plus 2, according to the type of pointer you have to calculate. 700 plus 1 and 700 plus 2. So this expression becomes value at 704 is equal to 30. Alright. So 30 will be stored here. 30 will be stored here. Right. So this is, there are many things we can talk about 1D array, but 1D array is one of the important topic. Many questions have framed on the 1D array. Now, coming to the 2D array, even in the GATE 2022, the question on 2D array was I think 3D array was asked. And in the previous GATE papers, you will see the questions on 2D array also. Alright. So let me explain how it is, how it works, or at least I can show you the diagram and how to access the elements. To declare a two-dimensional array, first I have to provide the number of rows in the two-dimensional array. You can imagine it like a matrix, 3 rows, and each row I want to have 5 columns. Each row I want to have 5 columns. I can initialize all the elements here also if I want to. Let me initialize it. Is equal to, let me initialize, is equal to first array 10, 20, 30, 40, 50, comma. This is the first row in the two-dimensional matrix or array. Second, 60, 70. Okay, I hope you can do that now. And finally, 70, 80, 90, 100, 110, 120 up to 150 and close it. Dot dot will not work. I am just telling you, you have to complete it. All right. Now, these elements will be assigned to the respective rows and column number, isn't it? The respective element. But how it is stored in memory, let us look at that. All right. First, you can note down this, that 10 to 50, 60 to 100, and 10 to 150. So there are how many elements total? So there are total 15 elements. Total 15 elements. Now let us look at how these 15 elements are stored in memory. All right. Let me make it bigger. Okay. So first of all, how much memory is allocated? Let us look at that. 15 elements, 15 into 2 bytes each is equal to 30 bytes. If the integer size is 2 bytes, then total 30 bytes. And these 30 bytes, let us assume, starts with 500 up to 529, total 30 bytes. These 30 bytes are divided into 3 parts to store 3 arrays within the collection of arrays. 2D is a collection of 1D arrays. So let me show here 1, 2 and 3. 3 parts. And in one part, in one we have first row of matrix 1, 2, 3, 4 and 5. Total 15 elements. Let us just do the calculation. If it is 500, 2, 2, 2, 2, 2, total 10 bytes. So it is 510. And this is 520. Right? 10 bytes, 10 bytes, 10 bytes. Considering integer is of 2 bytes. Now when it is a two-dimensional array, always remember the name of the array itself is the pointer to, not first element. Do not say that. It is not pointer to first element. It is a constant pointer to. Constant pointer to 0th array. It is a pointer to array. 0th array, this is a 0th array. And this array is 1D. 1D, 1D, 1D. Collection of 1D arrays is a complete 2D array. This is a first and this is a second array. Alright. Now with this understanding, it is a pointer to array. So let us understand the expressions now. Interesting. When I simply say A, the expression value is of course 500 only. And what this 500 represents? This 500 is the address of array. Next, a plus 1, if it is the address of array, a plus 1 would give us next array's address. And what is the next array's address? 510. So a plus 1 here is not 502, 504, 6, 8. So a plus 1 is not 502, it is in the one dimensional array. But in the two dimensional array, a plus 1 would be directly 510. As similarly, a plus 2 would be 520. 520. What is this address? It is array's address. Now the second step is you have to get the elements address. And to get the elements address, we have to put a dereference operator. We have to put a dereference operator. This expression gives us again 500, but this time this address is address of element. And what is the 0th element address? It itself is 500 only, isn't it? So array also starts with 500 and its 0th element also starts with 500, isn't it? That's why expression value is same here, 500, 500. It's a clear difference. Address of array, address of element, and what is the 0th element address? 510. 510. Similarly, you can say star a plus 2, that would give you 520. Now once you get the elements address, it is just matter of putting another star operator and get the value at that address. That's why star star a, the expression value is 10. Alright, let me initialize all the array as I initialized earlier. 10, 20. Alright, now what is the expression value? Value at, you see, first this star dereference. Star a is 500. Now just put 500 here. Value at 500 is 10. Value at 500 is 10. Alright. Now if you want to get, suppose, element 40. Now from 500 plus 1 plus 2 plus 3 you have to do. Okay, let us do that. So star a would give us 500 elements address, and if I add a plus 1, I will get next elements address. So by doing plus 1, I get next elements address. I want plus 1, 2, 3. So I can just say here plus 3 here. This would give me the address of this element. Alright, this element. And just put a star, you will get 40 as the expression value. Expression value is 40. You can print it if you want to. Now what if I want to get, let us take randomly, suppose 90. How to get this? First we have to get the array starts with 510. Alright. So how to get 510? A plus 1. You see, a plus 1 is 510. Now once you get the array address, now you get the 0th element address by putting first star. This would again give you 510, but this 510 is a elements address. Now with respect to that, plus 1 plus 2 plus 3, this would give you this address. What is this address? 512, 14, 16. So this expression value is 516. And now how to get the value at that address? By putting one more star, that is dereference operator. And the expression value would be 90. Alright. So in short, when I do a I j, what is the equivalent expression in the in terms of dereference operator? Let us look at it. It is star of first get the particular row. You see the element from row number this and column number this. First you get the row number, particular row, then the elements address, and then offset you have to add in that array, in that 1D array, or in that row basically, offset, and get the value at that address. Alright. So that is the two-dimensional array. Now, the next important topic is array of characters. Under the pointer to string, we have two ways of representing strings in memory. The first one is array of characters. Suppose if I want to store, suppose my name, how do I do that? Char name. You just declare an array of characters, and every element you can just initialize like this. And the last element you have to initialize as null character. Do not forget the null character. All the characters and finally the null character. Null character. So, where in the array of 10, how the characters are stored by their ASCII values. So, whatever be the ASCII value of k, that will be stored here, and /0, that is null character, and some garbage characters here, because we have 10 size of character array, isn't it? And the address of this first element, here the element is character, it is also an array, and as I said earlier, the name of the array itself is a pointer. That's why this 500 we are going to store or show here, it is pointing here. Alright. And with respect to this name pointer, you can just access the string. You can printf using %s format specifier, or you can copy to another string user strcopy. So you have to just use this pointer to do the string manipulation here. This is one way. Now can I change this to something else? Of course you can change. If I want to change the content of array, I can change it. I can simply say name 0 is equal to A, name 1 is equal to C, and name 2 is equal to E. So this will be replaced by A, C, E, A's. But do not forget to put a /0 here. So you as a programmer have to be careful. If you want to put a logical string here, the name of academy is here, but next character is already written as A, so that's why you have to replace it by /0. Name 3 is equal to /0, and it will be /0. Okay. Now if you print this string using printf statement, only A, C, E would be printed, and rest of the characters would not be printed. Alright. So, but if you don't put this /0 here, then A, C, E, N would be printed till the printf, or while accessing the array as a character array, up to /0 it is accessed. Alright. There is another way of storing the character string in memory, that is string constant. And how do you declare a string constant is like this, using a double quote. Using double quotes. If I give single quote, it is a character, single character. If it is double quote, it is string constant. And the string constant is allocated memory in the data segment of the process. Whereas, let me go back to the character array here, where these 10 bytes are allocated. Since I have declared this in a function 1, suppose function 1, it goes into the runtime stack, these 10 bytes. But if I have a string constant, no matter in which function I define it, no matter, function f1, f2, f3, main function, doesn't matter. The memory for 1, 2, 3, 4, 5 and null character 6, you don't have to specify null character in string constant. It will automatically given by the, introduced by the compiler. Alright. So these 6 bytes are allocated on the data segment of the process. 500, 501, 502 and so on. And when you have constant string, you should have a pointer to hold first character's address. That's why you need to declare char star as pointer to the character here. So with the help of this, we are going to have an arrangement. Locally, I have the variable s, it is a local variable. It goes into the runtime stack, but this goes into the data segment. That's why we have a local variable with the help of which we can reach to data segment and access the string. But the major difference between the character array and the string constant is, as the name of the concept itself is a string constant, you cannot change the string. It is not normal array. It cannot be changed. What it means? Means you cannot do like this. So star of s plus 0 is equal to a. I want to put ace here, ace and slice 0. If I do this, or if I do this, or if I do this, this is going to throw error. This is pure error. This is not allowed because the content itself is constant content. You cannot change the content. But you can make this pointer point to some other string, that is fine. This is not constant here. So memory wise, this is constant, but this can point to something else. And if I go back to the previous one, what I said, 1D array, this is constant, but you can change the content of array, that is fine. Exactly opposite behavior. Alright. So here lighting such statement is not allowed. But definitely, as I said, you can make this string point to some different string, that is absolutely fine. So in the data segment, I will have another string, suppose starting with 700, and 700 will be 700 will be stored in S. So S is now pointing to this other string in the data segment. This is absolutely fine. Alright. So that is the short description of what is the meaning of string constants. Alright. Now coming to the recursion. So pointer I have covered, okay. So we have few minutes left. Before that, quickly the recursion. Now how to tackle the question? I would strongly recommend you go for the tree method to solve the recursion problems. Let me take this program and try to explain you how to approach this question. First of all, the name of the function is count, and here I have called the function count. So it is a problem of recursion. Function calling itself is a recursion. Now, when you have the recursion problem, clearly show what do you want to do before the recursive call, task 1, or simply say A, some label you give, or task 1. This is a recursion call, and after the recursive call, task 2. So you bifurcate your program according to the placement of the recursive statement. It becomes easy for us to draw the tree and solve it. From the main function, I am going to call the function and pass 3 as a value. Alright, let us draw the tree. Now, what is the name of argument? N. Let's start. Now, every time you write the count in the tree, you have to write T1, T2, and in the middle of 2, we have a function call. Isn't it? So, in the middle of 2, we have a function call here, count. N is equal to how much? We will decide at that time. Just don't calculate upfront. We will decide at that time. And it depends on if this condition is true or false. This also we have to put in mind. So, sometime this statement might be skipped also if this condition is false. We will keep that in mind. Alright. Instead of that, I can put A here also if I want to. Just put a label A. This statement is label A. And in the diagram, I can just say statement A. So in the middle of task 1 and task 2, I have to perform the statement A. Let us start. Now this question, again one thing, has a static variable. Whenever you have a static variable, probably you should see my other session video where I explain how to solve what are the steps to solve any problem statement in C. Allocate memory for global variable, then static variable, and so on. Since this question has a static variable, the memory for this D is allocated when? At load time. Even before calling the main function, it is allocated. Okay? And once it is allocated, you can strike out that line from the program. At the time of execution, it is not considered. Alright? Strike out. Every time I call the count, you have to skip this statement because it happens only once at load time. Anyways, come to the task 1, printf. Let us write the output here also. Okay. Printf D. What is D? 1. Alright. I am sorry, N. Printf N. Let me correct it. Printf N. 3. Printf D. D is 1. 1. D plus plus. This task is over, you see. Now come to the second task. 3 greater than 1, true. Call the function and this time pass n minus 1. What is n? 3. So next time you pass, n becomes 2. See, next time you pass, this n second time becomes 2. Right? Now again, task 1, statement A, and task 2. Let us again come to the task 1. So we have to complete this first and then move to the task 3 of the first call, isn't it? So let us do the task 1 first. Printf n. N is what? 2. Printf D. D is what? 2. D plus plus. Call the function. Now this task is over. Again, call the function. This time it is 1. Repeat. T1, A, and T2. Let us do the task 1 more time. but this time n is 1. Printf n 1, printf d 3, d plus plus 4, task 1 is done. Come to the this task, a statement. 1 greater than 1, true or false? False, isn't it? 2 greater than 1, true. 1 greater than 1, false. So do not call this statement count. So this is over. Condition check is over. And we have moved to the next statement, printf. Now what is the printf, guys? Printf d. What is d? 4 printed. Now this task 2 is over. Means let us come back now. Okay, let me come back. Now this is over, means this statement is over. Now the task 2. Task 2 is simply print d, value of d, isn't it? You see, value of d. So print the value of d, again 4. It is only 4 only. D is 1 for all the calls because it is a static variable. So it is completed, come back, it is completed, and finally once again print the d value. So that's how I got the answer. So neat and clean tree would help you to approach the problem and get to the right answer without any confusion. All right? All right. And one of the very important topic in the programming language, I mean as far as the looking at the last question papers, is a static storage class. As I explained, the static variable d in the program. Okay. So try to solve as many problems on the static variables or the program which has a static variables. All right. So if you have any questions, feel free to send me email at this. So with that, I conclude this session. Any questions? All right. So if you have, feel free to just connect on with this. Thank you. 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test